All right, so this is quiz 22, Riemann sums, integral properties. This is what we were talking about yesterday. Compute the upper. Okay, so upper and lower is not tested on AP, depending on, but it is tested on some universities, right? Some universities want you to know this. For the given function f of x equals x squared over the interval negative 101 with respect to the partition. So here's how they break it down. So the delta x's are not equal. All these rectangles are different width. So I'm going to exaggerate the y and x axis, and I'm going to exaggerate y equals x squared. By exaggerate, I'm just saying that I'm making it big. There it is. I'm going to say, I can't even. Okay, I'm going to say that this is negative 1. Bam, negative 1. I'm going to say that this is positive 1. Bam. Bless you. Bless you squared. Okay. Here is from negative 1 to negative half. So I'm going to say that negative half is like right here. And then from negative half to half, I'm going to say that half is like right here. And then 1/2 to 3/4, that's in the middle between half and 1 and 1. Bless you. So I have 1, 2, 3, 4 rectangles. I think they told us that anyway. Oh, no, they didn't. But there it is. With the partitions, I have 4 rectangles. All right. What type of rectangle do I have? An upper or lower? Upper. So between negative 1 and negative 1/2, where's the highest point on that curve? X squared. So negative 1. So this kind of looks like an LRAM. It will look like an LRAM. Upper will look like an LRAM if you have a decreasing curve, which at the moment is decreasing. Between negative half and 1/2, the highest point is at negative half and a half. So they should both be the same height because it's symmetric on the y-axis. Does that make sense? Okay. Between 1/2 and 3/4, where do I have the highest rectangle? Where do I have the highest point on that curve, x squared? At 3/4. So an upper ram will look like an upper Riemann sum will look like an R ram if the curve is increasing. And between 3/4 and 1, where do I have the highest point? Okay. Yes, ask.
The negative 1/2 and the 1/2.
Mm-hmm.
Did you just use both points of intersection?
Yeah, because it's symmetric on the y-axis, so both points. Yeah.
Okay.
Ask.
Because why are they all different? Okay, so
Because these are just partitions. They're not.
Like a combination between RM and LRAM?
Yes, but remember, this is not tested on the AP. This is just some university giving you questions. So your professor probably wants you to know this. These are just random delta x. These are just random rectangles.
So it's not real.
No, it is real. If you go to UH is going to ask you this question. If you go to UT Austin and you're not an engineering major, you're probably just going to ask you LRAM or RRAM. If you go to UT Austin and you're an engineering major, they're probably going to want you to do this anyways.
It's a good thing I'm not an engineer.
Well, no. We got to know this, though. All right, here we go. All it is now, guys, it's just basic geometry. How do I find area of a rectangle? That's all you're doing. That's all you're doing, guys. Here it is. This rectangle here, I'll call this rectangle 1, rectangle 2, rectangle 3, rectangle 4. All right. I'm just putting n equals 1. It's not, 1, 2, 3, 4. Rectangle 1, width times height. What's this width? 0.5, 1/2. How do I figure out the height?
You plug it in.
Plug what in?
You plug the x coordinates back into the negative 1.
Into what? What am I plugging into?
The f of x.
Yes, that's how I got the height, guys. The height is dictated by f of x equals x squared. Plug in negative 1 into your equation and square it. That's the height. If you want, you can get rid of that negative 1 because any negative number, you can get rid of the negative. Any negative number squared is going to be positive. But make sure that you know what you're doing, the logic. What's the width between negative half and half? 1. And then I figure out the height. It doesn't matter which one you insert by typing in 1/2, and then you're going to square it. Plus, what's the width between 1/2 and 3/4? 1/4, parenthesis, and then what do? Squared. Plus, what's the width between 3/4 and 1? 1/4, and then what am I going to put?
How do we know to use 3/4 and not 1/2? Because we already used 1/2.
Okay, say it again.
How do we know to use 3/4 and not 1/2?
On the third rectangle?
Yes.
Because the 3/4 is what's on the curve of the x squared. See how the height is dictated by this x value. when I plug it into the curve and it gives me that y value.
Okay.
You know what I mean?
Oh, that makes sense. So this is quite literally the combination.
There it is. Well, okay, it is, but look what it's called. Upper, because I'm picking the highest points on that partition. Does that make sense, guys?
So then you go like from -1 to -1/2, and then -1/2 to 1/2,
Mhm.
and then you see which y value is the greatest.
Y value is the greatest on the curve.
Okay.
Because it says upper. If it would have said lower between -1/2 and 1/2, you would have chosen 0. Because that's the lowest.
Oh, okay.
Do you see it?
So it's not.
Yeah, so you would have technically no rectangle there.
Why would they choose like 0 and not like 1/4?
Because at 1/4, if it said lower, at 0, it's on the lowest point on that curve. Not at 1/4, but at 0. If it said lower, but did it say lower?
No. So
No.
if this was raised and it said
Upper.
lower,
If this was upper.
so if this like graph was raised and it was a lower unit sum, would it still be 0?
Okay, what'd you say?
So if the graph was raised, so say like it was x² plus 1.
Oh, okay. It would still be 0 because all it is this raised up 1, but 0 is still the lowest on that parabola. All right, guys. Tell me what this numbers is when you add them all up. Well, I guess. Okay. Cool or not cool? Okay, let's go to the next one. Compute the low. Now this one is which one? Lower, and I have 1 minus x squared, so that's just a parabola going down with a vertex at 1. So I'm going to exaggerate it. And from 0 to 1. So as a matter of fact, I just need quadrant 1. So here's quadrant 1, 0 to 1. So I'm going to... It's just a parabola opening downward with the vertex on the y-axis. Here's my partition. 0 to 1/4. I'm going to say 1/4 is... I'm going to say that's 1. So I'm going to say 1/4 is like right here. And then it says 3/4. I'm going to say 3/4 is like right here. It wants lower. On the partition between 0 and 1, where do I have the lowest point? At what x value do I have the lowest point? At 1/4.
I see.
Between 1/4 and 3/4, it says lower. Where do I have the lowest point on that curve? What x coordinate? Yeah.
Oh, you meant 0 between 0 and 1/4.
0 and 1/4. I didn't say that?
I thought you said 1.
Oh, my bad. What's up?
So whenever f of x is decreasing and concave down, is lower limit sum the same as right?
Yes. You don't even care about concavity. Even if it would have been concave up, as long as the curve is decreasing, a lower Riemann sum would be like an RRAM. But of course, these are delta x's that don't have the same. Between 3/4 and 1 at 1. So that one is like perfect. All right. All we're doing now is geometry, guys. The width between 0 and 1/4 is 1/4. And the height is dictated by the x coordinate on that curve. So 1 minus 1/4 squared, close, plus, there's only 2 of them, so we don't have to suffer too much. The gap between 1/4 and 3/4 is 1/2, open parenthesis, 1 minus 3/4, close it, squared. All right, we have 2 curves. Can you guys calculate that area for it? Well, I guess we can do it together. You know what? I'm going to be smart, and I'm going to go to y equals, and I'm going to type 1 minus x squared, so I don't have to push so many buttons. 1 minus x squared. And, oh, that's not a squared. There we go. So now that I have 1 minus x squared and y1, here's what I can do. 0.25 times alpha trace y1 at what y value? At what x value? 0.25. Close, close. Plus, and then what's the other? Well, I put 1 minus x squared and y1. So now I can just type in the x coordinate. And then plus 1/2. So 0.5. Open parenthesis, alpha trace y1 evaluated at what x value? 0.75. Close, close. So here we go. That number, I'm going to turn into a fraction. You can just push the math button. Frac decimal, I'm going to push enter. And there it is, 29/64. Do you see a 29/64? Are we okay so far, guys? Okay. All right. Here we go, guys. compute the upper Riemann sum for the given function, sine x, so a little bit of pre-cal, not a lot, on the interval 0 to pi with respect to partition P. So you can see why you guys have to take pre-cal. Did we all take pre-cal?
No.
What? We can take pre-cal? Guys, I was a pre-cal teacher. Don't make me cry. See if you can do it faster than me. All right, here is pi. Here is pi, guys. Right where you cross the x-axis. We all took pre-cal. Right smack in the middle is pi over 2. Pi over 6 is probably closer to x equals 0 than x equals pi over 2. Not probably, it is. So pi over 6 is probably like right here. And then 3 pi over 4 is smack in the middle between pi over 2 and? No, pi. We took pre-cal, right? We got it? Okay. So there it is. Hey, you got my calculator? Oh, you returned it? Oh, there it is. Sorry. All right, here we go. What we have 1, 2, 3 rectangles. They want upper between 0 and pi over 6. Where is the highest point? What x value has the highest point on that curve? So go to pi over 6, and there's my first rectangle. Are we okay? All right, check it out. Check it out, Miss Houston. Let's see if we get this one. Between pi over 6 and 3 pi over 4, at what x coordinate do I have the highest point on that curve? Pi over 2. Good job. You're going to be an awesome engineer. You're very observant. Between 3 pi over 4 and pi, where do I have at what x coordinate do I have the highest point on that curve? So now they're going to make me calculate 3 rectangles. That's not a big deal because we know a little bit about that. All right, so delta x times the height. So between 0 and pi over 6, so delta x is pi over 6. And then the height, well, the height is dictated by sine of x. So what's sine of pi over 6? 1/2. Sine of pi over 6 is a half. At pi over 6, according to square root 3 over 2, comma half. Plus the gap between pi over 6 and 3 pi over 4. Chop, I don't know that. Parenthesis. I'm just going to try 3 pi over 4 minus pi over 6. That's the delta x. Times sine of pi over 2 is 1. And then plus the gap between pi and 3 pi over 4. That one we can do pretty quickly. That's just pi over 4. Yeah, like 1 whole minus 3/4 of a pi. And then I'm going to multiply by sine of 3 pi over 4, which is square root of 2 over 2. All right, so let's see what that is. Pi over 6 times a half is pi over 6. So I'm going to put pi over 6 right here. I'm going to find a common denominator here. Let's see, what's 4, 8, 12? So 12 times 3 over 3 times 2 over 2. So what's up?
You find the difference between 3 pi over 4 and pi over 6.
Yes.
But then you find the y value of pi over 6, so that's the height value.
Yes, because width times height. 9 pi over 12 minus 2 pi over 12. So I see 7 pi over 12. Now, I make mistakes all the time, but make sure that, everything looks good. 7 pi over 12 times 1 is just 7 pi over 12. Yes or no?
Yes.
So that's the area of that rectangle. And then this one is, let's see, pi in the front, square root of 2 over 8. We're still okay? All right, I already see the pi square root of 2 over 8. That's this one. And now I'm going to add these two together and see if it's 2/3 pi.
Isn't that first one pi over 12?
Oh, yeah, it is. It is. How come you guys didn't stop me?
I just did.
Pi over 6 times 1/2. So this is pi over 12. All right, so here we go. I'm going to come to the outside. Pi over 12 plus 7 pi over 12 plus pi square root of 2 over 8. So they probably left this one alone because they have the radical. And then 7 pi plus pi is 8 pi over 12 reduces to?
2 pi over.
Yep, because 4 goes into 8 twice and 4 goes into 12 3 times. So 2 pi over 3 plus pi square root of 2 over 8. Letter C. So really, it's more arithmetic more than anything. The calculus part was just doing the rectangles. All right. What's up? What do you mean? It's the highest point on the curve. It says upper. Look, it's the highest point. Well, this one says lower. Yeah, you did. You did do that. Now, the previous one before that, I think this was an upper, and we did the upper. Highest point. Highest point. These are both the same. Highest point. Highest point. Now, it looks like LRAM and RRAM, so don't confuse it for that, but, you know? Okay. No, you're good, miss. All right, here we go. I haven't seen trapezoidal sums. I don't think trapezoidal sums is in this, but if you see it, email me immediately and I'll exempt it, but I haven't seen it. We're going to do that lesson today, trapezoidals, but with the short period, I'm like, no, let's just do it. All right, estimate this integral, 0 to 12, so that by the right endpoint estimate any. Okay, this is RRAM. They just don't know how to say RRAM. It says right endpoint, so that means the rightmost point. And I have how many rectangles? 6. So this is 3x squared, guys. Just exaggerate it. Chop, how do you exaggerate it? Like this. Just exaggerate it and go. See? And I'm going all the way to 12, so I'm going to say that this endpoint is 12. And then I just need to see, let's see, if I have 6 ticks, so that means the delta x is 2. So delta x, just like always, upper minus lower, divided by the number of rectangles. See? So let's see, I'm going to say 2's right here, 4, 6, 8, 10, and then 12. 1, 2, 3, 4, 5, 6. There it is. And between, I guess let me write it. 2, 4, 6, 8, 10, 12. All right, between the partitions, I am looking at what endpoint? Right or left? Rightmost. So here it is. Rightmost. Between 0 and 2, take the 2. There's my rectangle. Between 2 and 4, take the 4. Between 4 and 6, take the... Between 6 and 8, take the which one?
8.
Between 8 and 10, take the... And then between 10 and 12, take the... Okay, do you guys like the visuals? Are you guys visual learners? Okay. All right, take your calculator. All you're doing is width times height. The width for all of them is 2. So can I factor that out? So here it is. Factor it out. 2. Bracket. And I'm just doing width times height. Width times height. The height.
And then we use
2, 4, 6. Yep. 3 times 2 squared plus 3 times... I guess we can actually factor out a 3 as well. 3 times 4 squared plus 3 times 6 squared plus 3 times 8 squared plus 3 times 10 squared plus one more. 3 times 12 squared. If you want to be smart, you type in 3x squared in your y1. So here it is. I'm going to go to... Yep. I'm going to go to y1 and I'm going to type 3x squared. And then you just go 2. Here's my 2 factored out. Big parenthesis. Alpha trace y1 at 2 plus alpha trace. You don't have to put any squares because it's already embedded in y1. You guys know what I'm talking about, right? 2, 4. You can actually even do a sum if you wanted to, but yeah. 2, 4, 6, 8, 10, 12. 2, yeah. 2, 4, 6, 8, 10, and finally 12. Close. All right, there it is. 1968. Oh. Did I not square it? 3x squared. Let me see what I typed.
Did you press the 2 in the front?
2 in front. 2, 4. Oh, I missed one. Which one did I miss? 2, 4. Yeah. Why did I miss the 6th one? Did he tell me? Second insert alpha trace y1. Oh, look at that. Plus alpha trace y1 at 6. That's the only one I'm missing, right? All right. Now 2184. That one in there. Okay, good thing the other one wasn't in there. That would have circled it. Cool or not cool? All right, same thing on this one. By what? By midpoint. Here's my visual. It goes all the way to 12 again. So here's 12. Again, I have 6 rectangles. So I'm going to go again, the same thing. 2, 4, 6, 8, 10. But I'm not doing L or R. I'm doing middle. What's the middle between 0 and 2? 1. So go to 1 and a little above, a little below. What's the middle between 2 and 4? 3. A little above, a little below. Middle between 4 and 6. 5. A little above, a little below. And then I'm going to continue with that pattern. That way I don't know you guys repeating the same thing over and over. Do the visuals help, guys? All right. Doing the same thing. I come back. I go to y1. I'm going to type, what was it? 2x squared? So there's my 2x squared. I'm going to factor out, wait, do I factor anything out? Oh, yeah, because it's width times height. So I'm going to factor out 2, open parenthesis, alpha trace. Now it's 1, 3, 5, 7, right? Y1 of 1, because that's the middle between 0 and 2, plus alpha trace y1 at 3, plus alpha trace y1 at 5, plus alpha trace y1 at 7, plus alpha trace y1 at 9, and I got one more, plus alpha trace y1 at 11. 11, go to heaven. 1144. Cool or not cool? All right, here we go. Now the properties. Given that the integral from 0 to 1 of f of x dx is 1, 0 to 3 is 5, 3 to 6 is 3, and find 0 to 6. Okay, do a visual. Chop, I don't know how to do this. Not to scale. Yeah, if you already see it, that's fine. That's the whole point of this one. I'll say that's 1. Yeah, 0, 1, 3, 6. All right, so here's my visual. From 0 to 1, the area is 1. From 1 to 3, the area is 5.
Oh, and this is like what we did in right?
Yep, this is what we did yesterday. From 3 to 6, the area is 3. So this in blue, the area is 1. This in black, the area is 5. And that in burnt orange, is the area is 3. They want the area from 0 to 6. So all I got to do is just add them all. 1 plus 5 is 6. 6. Oh, wait. Did I do something? Oh, dang, guys. How come you guys didn't tell me that? Look, you guys picked me. I think I was listening to one of you guys. 0 to 3. There we go. Now it's correct. Now we're good. So all I got to do is add from 0 to 3, and then where that one stops, the other one better begin. So everything in black. Do you guys see everything in black? So everything in black, the area is 5, and everything in burnt orange, the area is, what's 5 plus 3? Sorry, miss. Don't get mad at me, Miss Cruz. Okay. How do we feel, guys? Okay. Let's go to the next one. Oh, yeah, we're going to have to do some stuff on this one. Not to scale. Starts at 0, and it wants me to go in reverse. Okay. Here's how we're going to do it. I'm going to draw a y-axis. It's not to scale, guys. Not even close to scale. I just draw a random curve. Not to scale. And I'm going to highlight all these. I'm going to color code them. I'm going to put this one in black. So 0 to 1. I'm going to say this is 1. And I'm going to go. So there it is. That one's in black. I'm going to put this one in blue. The 0 to 4. I'm going to say here's 4. And that one says 0. So I'm going to go all the way to the 0 here. So the blue contains a little bit of that black there. I'm gonna put this one in burnt orange. 4 to 6. And I'm gonna wait for you guys to catch up. If you have color coding, that I think that would be best, guys. And don't worry, I'm gonna make it super simple that you're gonna get it 100%. All right. So here's what I want. I want from lower limit 6 to upper limit 1. Don't even think about that right now. I want you to be thinking, how do I find the area from 1 to 6 of f of x dx? That's what I want you to think. So do you agree if I take the area from 0 to 6, so to get that area, I got to do the blue plus the orange. Are we still okay? And if I subtract the area in black, will that give me the area from 1 to 6? So here's what I got to do. I got to go integral from 0 to 4 of f of x dx. And I'm going to add the integral from 4 to 6 of f of x dx. And if you want, you can put that in a giant parenthesis, but you don't have to. So all that right there, that will give me the area from 0 to 6. Do you guys agree? Yes. And I need to subtract the area in black, so minus. So what's the area in black? From what to what? So if I subtract 0 to 1, will that give me the area from 1 to 6? Yes. So I'm going to put equal sign here. That's going to give me that. Are we okay? Okay, so check it out. Don't worry, we're going to get the right answer. You'll see. So the area from 0 to 4 is, for f of x, is 6, plus the area from 4 to 6 of f of x dx is 3. And there it is. And I'm going to subtract the area from 0 to 1, which is 1. So 6 plus 3 is 9. 9 minus 1 is 8. So I'm going to write integral from 1 to 6 of it. Then I do the properties, yes. So there it is. That's the area from 1 to 6 of f of x dx, which is 8. Now that I have that, remember yesterday we learned the properties? What happens when I reverse the limit? Not reverse. When I switch the limit, it turns negative. So I'm going to go, so, comma, integral from 6 to 1 of f of x dx is equal to what? Negative 8. Do you guys see how we did it? Do you see the logic? If you do this with logic, guys, you will always get it right. It's the rules from yesterday. Okay, you guys ready for this one? We're going to do it the same way, guys. Do you guys like the pictures, the visuals?
Can we do one without the visuals?
You don't want to do it with the visual? Okay. Should we do it without it? All right, here we go. From 1 to 4, it's 3. From 3 to 4, it's 3 again. From 1 to 6, it's 7. I'm trying to figure out how to get it from 4 to 6. I think the visuals is the easiest, but no, well, maybe you can do it without the visuals. Yeah, let's do it. I'm waiting for you guys to give me some hints. What do I got to do? So what do I got to do?
1 to 6 minus 1 to 4.
Yes, because that will get me so Miss Houston said, I have the area from 1 to 6. And if I subtract the region from 1 to 4, what am I going to have left? 4 to 6. Can you visually see that in your brain?
Yes.
So here we go. Integral from 1 to 6 of f of x dx. And if I subtract the area from 1 to 4 of f of x dx, that will give me the area from take the 7, subtract the 3. What's that? Thank you, miss. How do we feel, guys? All right, let's do the next one. No visual. See if we can do it. Yeah, you guys want to give it a shot first? All right, maybe one of you guys can come up and hook it up.
I feel like somehow we have to do the 2 to 6 times the 1 to 6. And then subtract that from the 91.
That will give us a 1, a 2. Actually, you're right. I think you got it right. I still think it's easier with a visual. I'm gonna do a visual. Is that okay with you guys? Okay. I still think it's easier with a visual here. 1, 2, 9. 1, a 6, and 6. Yeah, you're right. I think you got it, Houston. I think that's the answer. That's 1 of 6. That one's in black. That one's in black. And then this one is in blue. So I'm going to go 2 to 6. And I'm going to write this one in blue. Can you guys tell the difference between blue and black? Okay, because sometimes they're too close. And here is the 1 to 9 in burnt orange. So that's all of it. And they want the area from 2 to 9. All right, Ms. Houston, tell us what you did.
I took the integral from 2 to 6 and subtracted from the integral 1 to 6. And then whatever you get from that, get the integral from 1 to 9 and just subtract it.
So she took the area from 2 to 6. That's the blue stuff. And she subtracted the area from 1 to 6. And then she's just left with the area from 1 to 2. Do you guys see that? So this is going to give us the area from 1 to 2 of f of x dx. And then she went, I already got the area from 1 to 2. So she went, well, I got the area from 1 to 9, which is the burnt orange. And you just subtract. So you're just going to go area from 1 to 9 of f of x dx. And subtract the area from 1 to 2 of f of x dx. And you get area from 2 to 9 of f of x dx. I think pictures help me. But if you got a big brain. If you got a big brain like Ms. Houston here, you can just do it without pictures. But pictures help me. Even today, even though I'm super experienced, I still need to see pictures. So I don't have a big brain either. I got a picture. See? But do you see how the pictures help? So there it is, guys. So let's see. Area from 2 to 6, that was 4. And I'm subtracting the area from 1 to 6, which is again 4. So I get 0. So 0, that's just the way it worked out. And so I got the area from 1 to 2. So then all I got to do is take the area from 1 to 9, which is 7. And 7 minus 0 is just 7. It just worked out that it was 0, but it's not going to always be 0, guys. Are we still okay? All right, let's go to the next one. I think this is the last one. Is this the last one? Yep. All right, here's the last one, guys. The graph of f is shown below. So this is f. The area bounded between the graph of f and the x-axis between -5 and -4 is 17 over 6. So this area right here. So you can go ahead and do this. This area right here, that is 17 over 6. And I'm going to color code a different area. They told us. See? F and x-axis. Yeah. That's the exact area that they're telling us. The area bounded between the graph of f and the x-axis between -4 and 1. So I'm going to write this. So let me color code it for you guys. This one is purple. And I'm going to do the next one in blue. So this one is in blue. 125 over 6 between -4 and 1. And the area bounded between the graph of x and 1 and 2, so 17 over 6. I'll do that one in burnt orange. This right here, that is 17 over 6. They want the integral from -5 to 2. Well, that's easy to do. We learned that yesterday. Anything above the x-axis is going to be, everything below the x-axis is going to be, and there's a name for that. It's called signed area. Anytime you're dealing with definite integrals, it's signed area. Here we go. 17 over 6 minus 125 over 6 plus 17 over 6. Take your calculator, put them in there, add them up, and it's going to add up to, yeah, there's more negative than positive, so it should be 17 over 6 times 2
over 6.
plus 125 over 6. Oh, minus. Negative 125. Turn it into a fraction. Math, frac, enter. Negative 91 over 6. Bless you. There it is. All right, guys, we've done this whole UH quiz. I'll give you till next week until Friday, but we can probably get rid of it today, right? I'm not going to give you any work during lab, so maybe during lab we can knock this one out. And that's it, guys. We're done. Good job. I'll tell you guys right now.